Okay, my ID is 2018-0425. In this cell, I load the dataset and I print it just to make sure it's working. And then here, I separate the datasets into labels which hold the target class for each image and features which are the pixel values. And I normalize the feature range of 0 and 1s for performance by dividing all values by 255. And I reshape the pixel array into 28 by 28 matrices and print the shape. Here, I identify all the unique labels in the dataset to make sure we have 26 unique classes, one for each letter. I also calculate the class distribution to see how many sample exist for each letter. And it's then visualized with a bar chart. Okay. Um, Here, display image. I show the first 10 image with their labels. And the second function here, I randomly select image to make sure it's diverse and it's working. And then I take one sample for each letter to confirm um, they're all represented. Okay, here the neural network, I encode the label to convert them into suitable classification. And I also reshape the feature array to include any additional dimension to represent the grayscale. Okay, here I create the model, one layer with 32 filters, followed by max pooling, and dense layer with 64 neurons, and output layer with 26 neurons, one for each letter, using softmax. And it's optimized with Atom optimizer. Um, the second model, we have two layers, 64 and 128 filter, each with max pooling. And then I add dropout to reduce overfitting. And then I have like dense layer and output layer, uh, same as model 1, to make sure it's capture the pattern. Training model, um, both model here are trained with the data. Model 1 is trained for 10 epoch, and model 2 is trained for 15 epoch. And the validation data helps the monitor to perform, uh, so I can prevent the overfitting. Here I try to evaluate the both model. on the test data and compare their accuracy. They're both evaluated, and the better performer is saved in the best neural model file, so we can get the best model. Okay, here I just plot the training and validation accuracy and loss for both model, because it helps to understand how the model perform, um, whether it's overfitting or else. Um, and then here I test the saved model on a custom image. It's uh, processed by resizing to 28 by 28 and normalize the pixel and then reshaping it. The model predict the letter with softmax probability, and then I just display the prediction. That's for my part. Thank you.